In 1900, a group of Greek sponge divers pulled something out of the sea near the island of Antikythera. It was a lump of corroded bronze, unremarkable, forgotten for decades. Then, in 1951, a scientist looked closer. Inside that lump was a fully functioning mechanical computer. Gears, dials, astronomical calculations. A machine so sophisticated that nothing comparable would be built for another 1,400 years. That device was made in 87 BC. We like to think of history as a straight line, primitive to advanced, stone tools to smartphones. But scattered across this planet, buried, submerged, locked in mountains, are objects that completely shatter that idea. Technologies that, by everything we know about the ancient world, simply should not exist. Today, we're looking at 7 of them.
The antikythera mechanism, Greece, 87 BC. Let's start with the device I just mentioned, because the more you learn about it, the more impossible it becomes. The antikythera mechanism is roughly the size of a shoebox. It's made of bronze, and it contains at least 30 interlocking gears, some as thin as 1.4 millimeters, arranged with a precision that modern engineers describe as staggering. What did it do? It tracked the movements of the sun and moon. It predicted eclipses with a 19-year cycle. It calculated the positions of the 5 known planets. It even accounted for the irregular orbit of the moon, something that wasn't mathematically described again until Isaac Newton in 1687. Think about that. A device built 87 years before the birth of Christ understood orbital mechanics that stumped the greatest scientific minds for over a millennium after it was created. In 2016, researchers at University College London used 3D X-ray imaging to finally decode the front panel. They found it displayed a 19-year calendar, the positions of the known planets, and a dial that tracked the 4-year cycle of the ancient Olympics. Think about what you'd need to build this. Not just the astronomical knowledge, but the metallurgy, the precision tooling, the conceptual framework to even imagine that the heavens could be modeled in metal and gears. Where did that knowledge go? Scientists still don't fully understand how a civilization 2,100 years ago could have both designed and manufactured something this complex. No blueprints have ever been found, no workshop, no tools, just the object, alone, at the bottom of the sea. If that wasn't surprising enough, what we're about to look at isn't just a single object. It's a structure so massive, so precise, that we still can't fully explain how it was built.
2. The Great Pyramid of Giza, Egypt, 2560 BC. Yes, you've heard of the Great Pyramid, but I guarantee you haven't heard these specific numbers. The Great Pyramid of Giza is made of approximately 2.3 million stone blocks. They average 2.5 to 15 tons each. The heaviest individual stones, the granite blocks in the King's Chamber, weigh up to 80 tons, and they were sourced from a quarry in Aswan, 800 kilometers away. But here's what stops engineers cold. The base of the pyramid covers 53,000 square meters. The average error in the levelness of that base, 2.1 centimeters, across the entire base. Modern laser leveling technology would struggle to do better on that scale. The 4 sides are aligned to the cardinal directions, north, south, east, west, with an accuracy of just 0.05 degrees of arc. The sides are oriented to true north, not magnetic north. True north requires astronomical observation, not a compass, and they did it in 2560 BC. The Great Pyramid was the tallest structure on Earth for 3,800 years. Nothing surpassed its height of 1,465 meters until the Lincoln Cathedral was built in England in 1311 AD.
Egyptologist Bob Breyer once calculated that to complete the pyramid within Pharaoh Khufu's approximate 23-year reign, workers would have had to place one 2.5-ton stone block every single minute. For 23 years straight, working non-stop, day and night. No one can explain exactly how that was achieved. Theories exist: ramps, sledges, water lubrication, but every model proposed so far fails to fully account for the speed, the precision, and the logistical complexity of the operation. But it gets even stranger, because the next technology on our list wasn't built by an empire. It was built by a single man, alone, at night.
3. The Baghdad Battery, Iraq, 250 BC. In 1938, German archaeologist Wilhelm Koenig was sorting through artifacts in a museum near Baghdad when he found something that seemed completely out of place. It was a 14-centimeter clay jar. Inside the jar was a copper cylinder. Inside the cylinder was an iron rod. The top was sealed with an asphalt stopper. Koenig immediately recognized the design. He'd seen it before, in modern electrochemistry labs. It was a battery. In 1940, researchers replicated the design using grape juice as an electrolyte and measured a voltage of 0.87 volts. More recent replications using citric acid have produced up to 2 volts of stable electrical current. This object is dated to the Parthian period, roughly 250 BC to 640 AD. Alessandro Volta, who we credit with inventing the battery, built his first voltaic pile in 1800 AD. That's a gap of at least 1,700 years. Scientists still don't fully understand what the Baghdad battery was used for. Electroplating? Medicinal pain relief through mild electrical stimulation? A religious artifact? The surrounding context, the parchments, the tools, the workshop, was never found. If someone in 250 BC understood how to generate electricity, what else did they know? And how much of that knowledge simply vanished? Now, what if I told you that somewhere in the deserts of South America, there are drawings so large they can only be seen from the air, drawn with a precision that modern GPS surveys still can't fully account for? 4. The Nazca Lines, Peru, 500 BC to 500 AD. The Nazca Desert in southern Peru is one of the driest places on Earth. Almost nothing has changed there in 2,000 years. No wind, no rain, no erosion to disturb what the Nazca Lines left behind. What they left behind are called the Nazca Lines, and they are enormous. The largest figure, a hummingbird, stretches 93 meters. A condor spans 130 meters wing to wing. A spider is drawn with a single unbroken line 46 meters across. There are over 800 straight lines, 300 geometric shapes, and 70 animal figures, all etched into the desert floor by removing the reddish surface gravel to reveal the pale yellow clay beneath. Some of the straight lines run for 48 kilometers without deviation of more than a few centimeters. Modern surveyors using GPS have verified that their straightness rivals precision laser surveying. The shapes are only recognizable from the air. From the ground, they are just paths. The Nazca people had no known technology for aerial observation. Researchers have proposed that small observation platforms, kite-like structures, or basic grid mapping techniques could have allowed ground-level construction of the figures, but no evidence of those tools has ever been found in the Nazca region. What was the purpose? Astronomical calendar, water maps, ceremonial paths walked by priests? Scientists still don't fully understand the function, and they've been studying this place for over 80 years. If those lines make you question what ancient humans were capable of planning, our next entry will make you question what they were capable of building from a single piece of stone.
5. Puma Punku, Bolivia, approximately 536 AD. At 3,800 meters above sea level, in the Bolivian highlands near Lake Titicaca, lies a field of shattered stone that has confused archaeologists since it was first studied in the 1800s.
Puma Punku is part of the larger Tiwanaku complex, dated to approximately 536 AD. What makes it extraordinary isn't the age, it's the machining. The site is littered with massive blocks of red sandstone and andesite. Some weigh over 130 tons. But that's not the strange part. The strange part is the precision. These stones are cut with right angles so exact that a sheet of paper cannot be slipped between the joints. The surfaces are flat to within tolerances of 0.1 millimeters. Some blocks feature complex interlocking H shapes, identical in dimension, repeating with mechanical consistency, as if they were produced on a manufacturing line. The nearest quarry for the andesite is 90 kilometers away, across Lake Titicaca. No one knows how 130-ton stones were transported across water without wheels, cranes, or pulleys, none of which the Tiwanaku culture is known to have possessed. No one can explain exactly how these cuts were made. Stone tools cannot produce surface tolerances of 0.1 millimeters. Even modern diamond-tipped cutting equipment would struggle to match some of the right-angle precision seen in these blocks. The site was destroyed, possibly by earthquake, possibly intentionally. Whatever knowledge was used to build it was never written down. It simply ended.
6. Damascus steel, Syria, 300 BC to 1750 AD. For roughly 2,000 years, craftsmen in the Middle East produced a type of steel that was simultaneously harder and more flexible than anything Europe could manufacture. Crusaders who encountered it in battle reported that it could cut through a falling silk scarf and still slice through European armor. It was called Damascus steel, Wootz steel, or Pulad. Blades made from it were famous for their distinctive watered surface pattern, flowing waves and ripples locked inside the metal itself. In the mid-1700s, the technique simply stopped. The last known Damascus steel blades were produced around 1750 AD. After that, nothing. The craftsmen who knew the recipe either died without passing it on or took the secret with them deliberately. For 250 years, metallurgists tried to recreate it. They failed. Then, in 2006, a team of researchers at the Technical University of Dresden used electron microscopy to examine fragments of original Damascus steel. They found something extraordinary: carbon nanotubes, structures just a few nanometers in diameter, woven into the crystalline matrix of the metal. Carbon nanotubes were officially discovered in 1991. The ancient Syrian smiths were accidentally producing them sometime around 300 BC through a combination of specific ore sources, charcoal composition, temperature control, and flux materials. Exact details we still don't understand.
Scientists still don't fully understand how to reliably replicate original Damascus steel with the same properties. The specific Indian ore deposits that produce the unique chemical signature have been exhausted. The knowledge to process it is gone. And a nanotechnology that took us until 1991 to even name was being harnessed by metalworkers over 2,000 years ago. And now for the most unsettling entry on this list, not because of what was built, but because of what was understood.
7. The Saqqara bird and ancient aviation concepts, Egypt, around 200 BC. Aerodynamics before flight. In 1898, an Egyptian archaeologist discovered a small wooden carving in a tomb at Saqqara, Egypt. It was cataloged as a wooden bird toy and put in storage, where it remained forgotten for 71 years. In 1969, physician Khalil Masiha pulled it out of storage and noticed something strange. Unlike every other bird carving found in Egypt, all of which had horizontal tails, like actual birds, this one had a vertical tail fin. Birds don't have vertical tail fins. Aircraft do. The object is made of sycamore wood,
weighs 39.12 grams, and has a wingspan of 18 centimeters. Messiha and later aeronautical engineers noted that its wings have a slight dihedral angle, an upward tilt from the body that provides lift and stability. The cross-section of the wing matches an aerodynamic profile. In wind tunnel tests conducted in the 1990s, replicas of the Saqqara bird generated measurable lift. With a small rear horizontal surface added, a feature that may have been present and decayed, the model flew stably. Mainstream archaeology classifies it as a ceremonial or decorative object, but a minority of aerospace engineers and historians argue that the aerodynamic properties of the design cannot be accidental. That whoever carved this understood at some level the principles of lift. The Wright brothers flew at Kitty Hawk in 1903. The Saqqara bird was carved roughly 200 years before the birth of Christ. If ancient Egyptians were experimenting with aerodynamic forms 2,100 years before powered flight, what else were they modeling, testing, and imagining that we'll never know about?
7 objects, 7 civilizations, thousands of years apart, on different continents, speaking different languages, worshiping different gods. And yet, each of them arrived at something we cannot fully explain, something that reached beyond what we thought was possible for their time. Here's the uncomfortable truth that these artifacts force us to consider. Our model of history is built on what survived, what was written down, what was made of something durable enough to last. But most knowledge, most of what humans figured out over tens of thousands of years, was spoken, practiced, and carried in the hands and minds of people who are long gone. The antikythera mechanism survived by accident at the bottom of the sea. Damascus steel survived in blades. The Baghdad battery survived because clay doesn't rot. How many inventions didn't survive? How many discoveries were made, perfected, lost, and then rediscovered centuries later by people who had no idea they were repeating history? We think of knowledge as something that accumulates, that grows, that always moves forward. But the real story of human ingenuity is far stranger than that. It is full of peaks and valleys, of brilliance appearing suddenly, disappearing completely, and re-emerging from the dark. The ancients weren't primitive. They were just early. And in some ways, in some specific, inexplicable, extraordinary ways, they were so far ahead that we are still, right now, catching up to them. The question isn't whether they knew things we don't. The question is, what are we building right now that the next civilization will pull out of the ruins in 2,000 years, hold up to the light, and say, this shouldn't exist?